Now I want you to actually take data. I'm going to release the cart, and I'm going to give it a count of 3. And you're going to take your pendulum and synchronize it. Release it when I count 3, and stop it. Count the cycles and see if your last count doesn't happen simultaneously with the sound of the cart hitting the obstacle here. Okay, so what you're going to do is you're going to release the car when I count 1, 2, 3. I'm going to release the cart, you're going to release your pendulum. And you count cycles just like I did. 1, 2, 3, 4. And see if you can't get the pendulum length adjusted to where the second cycle ends at the instant the cart hits the end of the incline. Ready? 1, 2, 3. Okay. We're going to repeat that. Ready? 1, 2, 3. Okay. Now you can of course replay the video clip, see if those two runs at this slope are consistent. I'm going to give you a little bit of information here. I'm using sheets of paper. I'm going to write down the distance the cart traveled, and that distance was, I'm going to give you this in centimeters. That distance was 42.6 centimeters from the front of the cart to where it hit, to where the front encountered the obstacle at the end. So I'm going to write that down. Let's see, that's 46.2 centimeters distance. Okay, and we'll hold that up to the light so you can see it. Then we need to determine the slope of the incline. Now with respect to the table, the slope of the incline is found by measuring the distance, okay, up to where the incline is resting on the paper, the distance of this bottom rail here. Okay, the horizontal length of that bottom rail up to the point where the rail hits the paper is 44 centimeters. Now you can probably see that that rail makes a little triangle. Okay, the rail comes up, and then there's a gap between the rail and the table, so that this would be the hypotenuse of the triangle. Then we'd have an altitude at this end, and then you'd have a base of the triangle running back. The slope of that triangle, which is the rise divided by the run of the triangle, is presumably the same as the slope of the incline. In order to, okay, we've determined the run, we've determined the horizontal distance. I held the meter stick horizontal, I leveled it with the paper here, and measured the 44 centimeters. The next thing I want to measure is the thickness of the paper, and I'm actually going to take a micrometer and measure the thickness of the paper. So you can't see me doing this, I'm doing it off camera because it's a little cumbersome to do it on camera. But my measurement tells me that the thickness of the paper there was 1.26 centimeters. So to get the slope, I had 44 centimeters on the base and 1.26 centimeters here. Okay, so you see that we have this kind of data. And now I'm going to note that the time to travel 46.2 centimeters is 2 periods of a pendulum of length, well, you fill in the length. You just determined the length, okay? So again, let's get that up to where it can really be seen, and hopefully that's real clear. Okay, we see that we've got the 42.6 centimeter distance. Got a little picture of the slope. The delta t, the time interval required to travel the 46.2 centimeters in 2 periods, is 2 periods of a pendulum of length. You fill in the length here. Now you can write this out in your own words. The principle here is that you put something down that you'll understand. Later on, you'll put your information into a table, and you'll report that table to me. But be sure that when you write down information when you're doing an experiment, that you do it in such a way that you can immediately understand what it is you're seeing. Now we're going to continue the experiment in a minute, but we're going to do that on another clip.